Hey everyone, I'm going to be going over Leetcode 62 unique paths. So there's a robot in an n by n grid. The robot is initially located at the top left corner, so 0, 0. The robot tries to move to the bottom right corner, uh, grid minus 1, n minus 1. The robot can only move either down or right at any point in time, so either down or right. It can't move up, it can't move diagonal, can't move backwards. Given the two integers m and n, return the number of possible unique paths that the robot can take to reach the bottom right corner. And pretty conservative constraints. As we go into kind of the diagram here, uh, in following the problem description, we can either move to the right or down, and we need to find the number of ways to get to this finish position. So, very naive way of doing it, you can just follow a path to the finish line, and you can return that this is one possible way of getting there. And then there's different ways of getting there. You can go this way, and there we go. We're at the finish line. That becomes 2. You can keep going. You can eventually get to 28, and you should be able to reach a solution. However, this isn't the most efficient way to doing this. In order to break that down, let's instead cut this board down to just these rows. So we'll make it m equals 3, n equals 2. And with this, what we can do is if we're starting in this position here, so we're starting right here, and we try to get to the finish line, we can go here, and then we can go here. And the biggest thing to take away from this is when we get to this position again, once we've already reached the finish line, we don't actually have to go down this final path here because we already know that from this position, we already know how many possible ways you can get to the finish line from this position. And there's only one. So you can just append this value, you can add it to whatever the number is from here. So this follows a very nice recursive structure. So at any point in the board, if we've already gotten the number of ways to get to the finish line from here, we can save that in this position. And so any other iteration that gets here, we can just add the number of ways that we already pre-calculated to get the answer. This will make more sense as I go through the code. So what I like to do is I like to have a local function here, and we'll just call this DFS, and we're going to pass in row as an int and c column as an int, and we're going to return an int as our return function because this is just the number of ways that we're going to return. And because we can only go to the right or down, we can't go backwards or up. We only need to check if r equals m or c equals n, because that would imply that they're out of bounds. So r equals m would be out of bounds this way, r equals and c equals n would be out of bounds this way. If that happens, we just need to return 0 because that's not a valid path to the bottom right corner. And then we need to check if RC as a tuple equals the tuple of m minus 1, n minus 1, not be n minus 1. If that happens, we know that's a valid possible way to get there, so we'll return 1. Next, all we have to do here is we need to return the DFS of going to the right, which would be R C plus 1, plus the DFS of going down. So that would be R plus 1C. And if we just initialize this with R equals 0 and C equals 0, because that's our starting point, this should give us the right answer. Now, this would time out if we tried to apply this to some bigger inputs. So let's take what we did in this step here and let's apply it here. So we can, every time we reach an answer at a specific point in the board, we can basically just save that. And that's pre-calculated if we ever reach that position on the board again. So if we have the memo here, which we will initialize to a dict of a tuple of int as the key, and the value will be the int, the number of ways to get there from that position. And we'll initialize this to a empty dictionary. And we'll first check if RC in memo, we'll just return memo of RC. And then all we have to do down here is instead of returning the DFS, we save it to the memo in that position, and then we return the memo. There we go. And if we submit, there we go.